Question number 16. A playground merry-go-round is at rest, pivoted about a frictionless axis. A child of mass m runs along a path tangential to the rim with a speed v and jumps on the merry-go-round. If r is the radius of the merry-go-round and I is the moment of inertia, then the angular velocity of the merry-go-round and the child is. Alternatives are mvr divided by mr square plus I, mv by I, and mr square plus I by mvr, and the last one is I by mvr. Let us deposit the problem like this. If this is a merry-go-round and the radius of that one is r, a child is running tangential to that one. So if the mass of the child is m, velocity is r, then the radius of the circular path in which the child is coming is r. So we can say the angular momentum of the child is mvr. That should be equal to, when it is the child is jumping into the round, the merry-go-round rotates with an angular velocity omega. So angular velocity of the omega is given, then the angular momentum of the merry-go-round is I omega plus the angular momentum of the kid when the merry-go-round is rotating is m omega r square, because we are using the same relation like this, but we are in that case we are using r omega. So that is why it is mvr I omega m omega r square. Now we want to know omega, so we will remove omega from here. So I plus mr square, that is collecting omega we'll have like this. So we want to calculate omega equal to mvr by I plus mr square. So mvr by I plus mr square. So correct choice is A is the correct answer.